So we've got our new rules now, taking derivatives of logarithms, taking derivatives of exponential functions. First, got to recognize what you're dealing with. On this one, we got an exponential function. We know that because our variable x is up here in the exponent. So using our new derivative rule as it applies for exponential functions, f prime of x here is going to equal. All right, what's our form that we need to follow? Got your exponential form. So you start by writing same exponential form times natural log of that base times derivative of that exponent. So exponential form 10 to the x squared times natural log of the base, so natural log of 10, times the derivative of the exponent, exponent's x squared, so derivative is 2x. We leave it in unsimplified form. That's our derivative. That's it. All right, so you got a logarithmic function. Specifically, it's a natural log. But if we follow our general form here, all right, this would be my general form, one of these two ideas. If I take the top idea, it's going to be 1 over whatever follows the logarithm times the natural log of the base of the logarithm times the derivative of that part that followed the logarithm. So how that corresponds to this problem. F prime of x is going to equal 1 over the part that follows the logarithm, so x cubed plus 1 times the natural log of the base. The base value is e, so we say natural log of e, which really makes this optional, right? Because natural log of e is just 1. Then tack on the derivative of that part that followed the logarithm. So the part that follows the logarithm, x cubed plus 1, take that derivative, simply 3x squared. That's one way to write it. Other way to write it, and either is acceptable. The other way to write it, you set up a great big fraction. Got the same denominator as before, the x cubed plus 1. Got natural log of e canceling out to 1. Or just leave it as natural log of e. That's fine too. But then on top would go the derivative of that part that follows a logarithm. So on top is that 3x squared. Either way is acceptable. All right, so derivative of another logarithm, different base value this time. Anybody know what the base value is, by the way? It's 10, right? Well, it's not written there. As long as it's not an ln. When it's not written there, it's 10. So following the same rules as the previous problem. F prime of x equals, if we follow the consistency of the first approach like we did on the last one, it'd be 1 over. 1 over the part that follows the logarithm, which is 2 plus sine of x, times the natural log of the base, the natural log of 10. It's not the natural log of e, can't just cancel out to 1 there, it has to stay as the natural log of 10. Tack on to this the derivative of that part that follows the logarithm. You got 2 plus sine of x is that part. 2 goes to 0. Derivative of the sine of x, simply cosine of x. So one way to write it, other way to write it, cosine of x would be on top there. So we got our product here. We're going to rewrite this function first. We know those roots we need to raise. So y is going to equal x squared times, the entire root is over the natural log of x. So it's the natural log of x, all of which would be raised to the power 1/2. We've got our product now, following our product rule. taking the derivative of y, we've got dy dx equals. First part of the product, x squared. Take that derivative, get 2x. Multiply on, second part of the product. Natural log of x as a quantity raised to 1/2. Add on. First part, x squared unchanged, times derivative of that second piece. The second piece is a quantity raised to the 1/2 power. Got to bring that 1/2 down. Got to apply a chain rule here, right? Inside, that natural log of x stays. New power becomes negative 1/2. But then tack onto that the derivative of the inside. The derivative of the natural log of x. That's a new rule for us. What's that derivative? Specifically, it's 1 over x, right? If you went through the general form, you'd say 1 over x times the natural log of e times that derivative of x, which is just 1. So you get 1 over x back either way. That's our derivative. So, similar looking problem. Kind of like I did on the last one. Let's rewrite some things. Rewriting that root, knowing I got to raise the root, we've got y equals x squared times the natural log of square root of x. We change to x to the 1/2. Now, I feel like at this point, it'd be nice to review one of those log laws. I've got a log law where when you take the logarithm of some value here raised to some power, you're allowed to take this power and bring it down to the front of the logarithm. So if I rewrote this function a little bit further, it'd be y equals, if I'm bringing the 1/2 down and this is all multiplied, let's just bump the 1/2 to the very front. Right? We're used to seeing the values in the lead position anyway, so bump that to the front. Got x squared, natural log of x. Now remember, I just applied one of the log laws there. I didn't take a derivative of anything, so I'm not adjusting for powers here. If this is my product, now when I apply the product rule to take this derivative, dy dx is going to equal derivative of the first part. So bring down 2, multiply to 1/2, get 1. Got x to the first left. X times the natural log of x, second part unchanged, plus first part unchanged, times derivative of the second. So derivative of the natural log of x, as we talked about in the last one, specifically that's 1 over x. So that's one way to do that. Now you could have used a product rule from the start off of this step. It's just you get a different looking answer, and since we're not simplifying, it would actually still be correct. Okay? All right, let's take the derivative of this one without any simplifying to start. If we dive right in using what we know about derivatives of logarithms, then let's follow the very general form here. General form would take a derivative of a logarithm. Starts with 1 over. It's 1 over whatever follows the logarithm. So the part that follows the logarithm, got x plus 1 over the square root of x minus 2. It's that piece times the natural log of the base on the logarithm, which is e. So this would be an optional piece because, again, that goes to 1. Where we go from there, we tack on the derivative of the part that followed the logarithm. So this is the part that followed the logarithm. That's a quotient. Got to use my quotient rule. So I take the derivative of the top, which is 1, times the bottom, minus top, times derivative of the bottom, x minus 2 raised to the 1/2 power. Derivative would be 1/2 x minus 2 raised to a power of negative 1/2 times derivative of the inside, which is just 1. And this is all over bottom part squared. So x minus 2 is a root squared. Could just say x minus 2. Believe it or not, especially since we're leaving this in an unsimplified form, that's an acceptable answer. But let me show you another take on this same problem. See, if I know my laws here for logarithms, I could take this same function. Since I have a quotient here, I've got this a over b form, I could rewrite it as the natural log of that top piece, x plus 1, minus the natural log of that bottom piece. That bottom piece having a root, I'll write as x minus 2 raised to the 1/2. Now we talked about this on the previous problem. If you're taking the log of some value here raised to a power, you can take that power, you can bring it down. So what we have here now is a new function to take the derivative of. So I'll say dy dx equals, got one logarithm here. I take the derivative as it applies to that logarithm. It would be 1 over the part that follows the logarithm, x plus 1. If I want to include this, I'd say the natural log of the base, natural log of e. So just 1. Tack on the derivative of what followed there. What followed was x plus 1. Derivative is 1. So there's the derivative for the first part. Subtracting for the second part. Well, I got a 1/2 that's going to get multiplied to the derivative of the natural log of x minus 2. So how we take the derivative of the natural log of x minus 2, very similar to how you take the derivative of the natural log of x plus 1. It's going to be 1 over x minus 2 times natural log of that base value of e, optional piece, right? Because that's 1, times derivative of the part that followed the logarithm being x minus 2, so that derivative would just be 1. If I leave it in the unsimplified form, there's another take on a derivative of the same problem.